Hello, my name is Neeraj Sagar. I am assistant professor in Ajay Kumar Engineering College, and my topic is from design and analysis of algorithm. And today's my topic is Fibonacci heap, and which is very important topic of this subject. So let us discuss about Fibonacci heap. See, this Fibonacci concept is introduced by Friedman and Tarjan in 1986. The basic idea about this is basically it is the topic of your advanced data structure, and uh, you have to know about binomial heap before reaching this topic. So this topic is similar kind of binomial heap, but less rigid comparatively to the binomial heap. See, binomial heap, if I am discuss about the binomial heap, it is a collection of heap trees in which if I am taking bk, see, binomial tree with this order k is an ordered tree. Okay, this is an ordered tree defined recursively, where k is defined as order of binomial trees. Okay, here k is the order of the binomial tree. Fine. See, this is binomial tree, k is the order of binomial tree, and we recursively call which is an ordered tree. See, we design this binomial tree in this format, like if this is b0, order of this binomial tree is 0. See, what is this? This is the b1. Here this node represent the bk minus 1, and this node represent the bk minus 1. If order is 1, then 1 minus 1 0. Okay, so this node is here, and again 0, and we connect these nodes. See, the order of this tree is b2, right? bk minus 1 means b1. Okay, this part is b1, this part b1, sorry, this part is b1, this part is b1, and this part is b1. We connect these both b1 and b1 and make a tree which is order of b2, right? If this is b3, means its order is b3, right? So if this is b2, then this part is bk minus 1, means b3 minus 1, which is b2. So this part and this part is b2, right? So we connect these different b2 and b2, and this gives you the b3 binomial heap, which is of order 3. See, this is the way we design this tree. Okay, see, now we discuss what is Fibonacci heap. You have to know about this concept binomial heap, then you can come for this topic. Okay, Fibonacci heap, basically it is a tree which is a collection of heap tree, likewise binomial heap. Okay, but in binomial heap, this binomial heap is a ordered in ordered way, but Fibonacci is organized in unordered way, right? Okay, I hope you got the basic idea of this Fibonacci heap. See, let us take the next. I am going to discuss about Fibonacci heap, in which we discuss the structure of this heap. See, first topic is set of heap ordered trees. Okay, set of heap, because we have collection of heaps and we ordered these trees. Okay, see, first of all, we do not organize these in ordered way like 1 2 3 b1 b2 b3. We are not organized in this way. We can use any order in this Fibonacci heap. See, set of heap order trees, it is, we have to check each parent smaller than its children, okay, because at the root node we have to mention minimum key. So every node, parent node should be smaller than its children node, right? If you can see here, these are the root nodes, right? 17, its children is 30. Okay, this node contains 30, means 30, it is greater than your parent. Again you can see 35 is greater than its parent node, 26, it is greater than its parent node. This is the way we organize this Fibonacci heap. See, in binomial heap we cannot use uh, more than one. I mean, if this is of b0 and this is b0, in binomial we cannot use this approach, but in Fibonacci we can use same order in a heap. Okay, in Fibonacci we use the same order in a heap. I hope you get this point. See, this is in some points we can say Fibonacci heap much more differ from your binomial, right? Let us take next point. In Fibonacci heap, maintain pointer to minimum element. If you are using this minimum Fibonacci heap, see, you have to point the minimum. If you see which one is minimum, these are the heaps and these are the different roots node. Okay, right? So which one is minimum? 3 is minimum. So I mention the pointer as minimum to the 3 because this is the minimum key, right? Next one is set of marked nodes. See, in binomial we don't have marked node, but in this Fibonacci heap structure we have marked node, and most of the time we use these marked node uh, during the decreasing of key, right? When we are going to discuss about decreasing a key, then these comes into the picture, right? See, 26, if it is marked, then it is, it's means it is true. This node is also true and these are false. If we have unmarked, then it is false, right? I hope this structure is clear to you. Now we have some notations in Fibonacci heap like these, as you see on this slide, and means number of nodes in the heap. See, if I count number of nodes in the heap, the number of nodes means, what is the count? N, 14. Okay, 14 number of nodes are present here currently, right? Rank of x, or we can say degree. Okay, basically degree, what is this? Number of children of node x, right? See, if I am talking about 3, 3 is a root node, and what is the rank of this node? 1 2 3. It has 3 children, right? So rank 3. Next, rank h, maximum rank of any node in heap, right? Rank h, right, means, see, it is about the particular node, okay, or this is regarding the complete heap. In the complete heap, which one has maximum rank? This node, 3 with 3 children. So maximum yani ki rank h is equals to 3, right? Next, tree of h means number of trees in a heap. I already said that in a Fibonacci heap we consist collection of heap trees. So in this 1 2 3 4 5, okay, 5, we do have 5 trees, right? Next notation is mark H, means number of marked node in heap, right? So here we have 3 marked node here, so we write it 3. So these are some notations we have to know in Fibonacci heap. See, here in this slide I mentioned some properties of Fibonacci heap. First one is it can have multiple trees of equal degree. Okay, right, means multiple heap of similar degree. See, this is B naught, this is B naught. We can have in this Fibonacci, unlike binomial heap, right? And each tree does not need to have 2 raised power k nodes. ठीक है, it is not necessary कि tree हमारे tree में 2 raised power k आपके nodes होनी ही चाहिए. Okay. Now next point is all the trees in a Fibonacci heap are rooted but not ordered. This point I have already discussed that in this heap we do not use ordered of tree, right? Like in binomial we use B naught, B1, B2, B3. We organize the heap, binomial heap in this way. First we have to write this order tree, then this order tree, then this order tree, then this order tree, and connect all these trees. Okay? We normally use this approach in binomial heap, but we do not follow this approach in your Fibonacci heap. See, next property, all the roots and sibling are stored in separated circular doubly linked list. See, uh, uh, what does this point needs to explain? See, here this is the heap. All these are stored in a circular linked list. Like this is connected as this. This is connected as this. Doubly circular way, and this, see, this connected as this, right? This connected as this connected as this. So we connect all the nodes, we stored all the nodes values in a circular doubly linked list in this way. Fine. See, next is the degree of node is the number of its children. Okay, as I can say, I said a rank is equivalent to the degree. If you can find out the rank, then it is equivalent to the degree. So node of any x is, what is this? Degree is equal to the number of x children. Okay, I just explained this point. Now next I explain about the true and false, marked and unmarked your nodes. See, each node has a mark attribute in which it is marked true or false. Okay, fine. Then false indicates the node has not any of its children, right? And true represent, what is the true represent? That the node lost one child, right? So we newly created a, whenever we create a any node into the existing heap, we always marked it as a false, right? Then next point, in binomial heap we do not calculate the potential function, but in the Fibonacci heap we calculate the potential function, which is potential function of fh. T is the number of tree in the Fibonacci heap plus 2 into number of marked nodes into the Fibonacci heap, right? So these are some properties of Fibonacci heap, which is very different from binomial heap, right? Now there are some important operation of Fibonacci heap, just like in binomial. Binomial heap also consists these operations. Now in Fibonacci heap, we have make heap, or you can say create or insert heap. Sorry, create heap. Okay. Next operation is insert, then find minimum, extract minimum, union, decrease key. Okay, in which all these are the important operation. Okay, but uh, extract minimum and decrease key, both are very important operation of Fibonacci heap. And most of the time in AKTU these question arises from these operations. Okay, so these both are very important. And comparatively, make heap, insert heap, find minimum and union, these are very easy operation. Okay, which consist order of 1, all are take order of 1 complexity, order of 1, and this consists order of log n, and this consists order of log n. Fine. So let start with the make heap. See, make or create a heap in which we do not have any key, any heap there. Okay, we allocate and return the Fibonacci heap with objects where number of heap is 0, yani we don't have any tree here. And minimum heap, obviously if we don't have any heap, any tree into the heap, then obviously minimum heap is equivalent to the nil. So we need to insert nodes into this heap, okay, to perform various operations. Next is it is operation of insert of Fibonacci heap. See, in insertion, let us we do have this existing heap, right? Into this we need to insert this 21. How do we add these 21, this 21 into this heap? See, we need to create a new single tree, means we have to add this 21 over here. But the question is where I have to enter, where I have to mention this 21 into this existing heap. So next is, when you create as a singleton tree here, now next point is to add to root list, update minimum pointer if necessary. See what this point want to explain. I just enter 21 over here. Okay, this part is your root part, right? This is your root part. Fine. I just insert 21 at the root. Okay, if this entered inserted node consists of minimum value, then I marked it as a minimum. But as I can see, already 3 is very less than 21, so I don't need to update minimum pointer. Fine. So this is very simple approach to insert any node into the heap, because we can have multiple in Fibonacci property. I just explain, we can have multiple nodes, multiple trees of same degree. Okay, no issues here. Next, extract minimum key. See, this is, as I said, this is very important topic of Fibonacci heap. How do we extract minimum key? Extract means I need to extract these 3 from here, because this is the minimum key into this heap. So how do we perform this? See, delete minimum. I need to delete 3 from here, meld its children into root list. Now its children are these. Okay, I just need to meld these children to the root node and update minimum accordingly, right? See, I performed it here. I just removed 3 here, which is minimum, and melded to root node, right? See, now 1839, these all are the children's. Now these are the root node. Okay. Now see, this is fine. Okay. Now what we need to do next is consolidate tree so that no two rows have same rank. Okay. Now in the extraction of minimum key, uh, we have to make sure this point. Okay, we have no two roots have same rank. Okay, how do we going to do this? Let us discuss. Okay, see, this is your rank. ठीक है, 0 1 2 3, this is your rank. यानी कि in this tree we do have rank of 0 1 2 3. If let's start from here. Okay, this is my current, ठीक है, where I am standing, fine, and this one is your minimum. I updated it. This one is your minimum key. Now current is this node, and this is your, what is the rank of this node? 1, right? B1, if you remember, B1, ठीक है. Then I make a point from here. I make a pointer from this node to this table. Okay, fine. Now next I connected this pointer with this node. Now if I go here, what is the degree of this? Is 2, right? Now if this degree of this tree is 2, so I make a connection from this table with 2, make a pointer. Okay, 2. Now 3, 23. Now I am at this position at 23. Fine, 23 is my current location. I order of this node is 0, so I make a pointer from 0 to this node, right? Again, if I go here, I have already pointer with this node, but here now my current position is 17. Its degree is B0, means same. So how I resolve, because I cannot make again a pointer like this. I cannot make this. Okay. So what I am going to do, I just I just resolve it by adding 23 into its 23 as its child node, right? Now its degree is, what is its degree? I just, what I have done, 23, make 23 as a child node of this 17, right, to resolve this problem, because I cannot point say 0 pointer to the nodes of same degree. So now 17, make it as 23 as a child, right? Now what I am going to do, its order is now 1, and I already point 1 to this tree, So how do I go? I am going to resolve this problem. See what I am going, link 17 into the 7, fine, because 7 is the minimum key. So I make 7 at the root and make this as its children, right? See, 17 13 at its root, because this is the minimum key, and shift and make 17 23, this tree as its child, right? Now my situation has been resolved. Now this 2 point here now, but problem is its rank is 2 and this rank is 2, same rank, and for extraction minimum key I cannot allow this. So how do I resolve this? I just make 7 at the root, but 24 at its children. How do I resolve this? Because already this pointer points this node, I cannot say do this. So how do I resolve? See, make 7 as at root node and rest of the tree as its children, right? See, now its order is 3. So make a pointer with this table from 3 to this node. Now its order is 1. Make a pointer. Fine. See, 52. Make a pointer. It's 0. It's 1. And its order is 3. No issues. And its order is 1. Again there is a issue. How do we resolve? See, this tree and this tree both have same. So we connect 41, 18 is a minimum. So make this tree as a child of this node. See, so now its order is B3, its order is 1, 0, sorry, its order is 2, no issues. This is the way how we can extract minimum heap. Whenever we extract minimum key, we have to follow all these steps which I discussed here. Okay, this is the way how we can extract minimum key. In next, if I want to extract this 7 from here, so delete that 7 from here and meld its children at root node, right? So this is the way we we perform the operation of extract minimum key. See, this is my final heap, Fibonacci heap after extraction of 3. So this is a little bit very lengthy method, and that's why this is very important operation of Fibonacci heap, and I hope this is clear to you. Okay, if you have any doubt in this operation, you can comment me. Now next, which is very important, that is the decrease key algo. Okay, fine. For this we are going to solve an example, but using this algo, right? See, here we have the Fibonacci heap in which we are going to decrease a key, right? See, here 7 is your minimum, okay, and this one is your marked node. This one is your marked node. I need to decrease a key. Okay, for this we have to concern about these points. See, if heap order is not violated, just decrease the key of X. Okay, so how do we do this? See, let's say this is my heap and I want to decrease a key X, means 46 to 29. Fine. So I just want to decrease 46 to 29. Then for decreasing a key, we have these 3 algos. First decrease key, then cut, and then cascading cut, right? See, my current key is 26. I want to decrease it to the 29. See, H belongs to your heap. X is your current value of the heap, okay, which is 46. Key of X is 46 and this is your K. Now the condition is K, it should be greater than key of X. Your K is 29, right? 29 is greater than key of X is 46. If this comes, then it print the error. Yani it means it should be less. Okay, when the value of your current node, it should always less than your updated value. ठीक है, means 29 आपकी क्या है, less है 46 से. Okay, there is no issues, fine, we do not print error here. See, now 29, key of x currently is 46, now 29. So we update this, we update 29 with the 46. See here, this is 46, we updated it from 29. ठीक है, यही हमें करना था. Next, after this we mark parent of x as y, parent of x as y, this is y, right? Now if y does not equals to nil and key of x is less than key of y, ठीक है, key of, obviously this is not nil, it consists some values, it should not be null. ठीक है, यही हमने देखा. Now 46 we change it 29, it should be greater than, means this value key of x, it should be less than key of p or y, but this condition is false here. Okay, 29 is greater than 24, so we don't need to do anything, just update it here. Okay, we cannot go further. See, we cannot go further here because the condition is false here. Okay, it just, after this we just need to check for these values. If key of x is this minimum value, because it's not in the root, we don't need to check anything here. Okay, here your condition 29, key of x is, it should be less than 24, but this condition become fail here, so we do not need to exceed any process. See, now next, your pointer is same here because we this part is on the children's node, right? Now second case, if I want to decrease 29 from 15, अब मैं क्या करना चाह रही हूँ, 29 को डिक्रीज करना चाह रही हूँ 15 से. सो अगेन वी फॉलो द सेम प्रोसेस. सी, see, now your x is 29 and k is 15, is 15 is less than your key, 15 is less than your current key 29, then we do not go at this point, we just switch to this point. Now update 25, update your key is 15, now your key of x is 15. Okay, let's check, we update 29 as 15 here, right? Now we check the parent node. See, mark parent of x, now it is 15, parent of x as y, and check if y it should not be equals as nil and key of x is less than key of y, means, see, I marked its parent as y, right? it is not nil, and of course it is, see this one is greater than and this is less than. Now condition, your this condition is satisfied. See, your this condition is satisfied. Now cut HXY. Find H means your current heap, X, what is it? Your X is 15. See, 15, and your parent is 24. You just need simply cut this by, now I call this function cut. Remove x from child list of y, मैं remove करूँगी, then add x to the root list. Root list में I need to add and check p of x is nil and mark x as false. See, check for this these steps. See, I change it here, check y, fine. See, this one is less. So what I am going to do now, y is not equivalent to nil. So I just, in the cut algo, I just cut this part and make it as a root node. Fine, I make it as a root node. Now your x is this, this part is your y. Okay, this is the parent of x, parent of x. Now if this is a marked node, I unmarked it. Okay, its parent is now nil, it does not have any parent. See, we follow these 4 steps here, right? Now after cutting, we check for cascading cut. Cascading cut in which I check parent of the parent and check that is it does not equivalent to the nil. Then if mark y false, then mark y as true. Okay, see, I change it, I cut it, then see, this is the z. Now I check, it is marked as a parent, I check here z, obviously this is not nil, fine, this is not nil. So that's why what I am going to do according to the cascading algo, I just mark, this is marked as true but false, but I marked it as a true according to the cascading algorithm, right? So this is how we perform according to the algorithm. Now I am going to decrease key x from 29 to 15. This I have already done. Now what I am going to do, this part is your 35. Now I am going to decrease it by 5. See, 5. Same, I just check this is your x. Okay, it should be less than your 35. Okay, this value is true, 35 is greater than 5. Okay, no issues, it should be less. If I check, if mark it as a parent y, right, I mentioned here, see 5, see 25, 26 is greater than 5, 26 is greater than 5. See, 5 is less than 26. Now we this part is okay, but I am going to do, I just cut it from there and make it as a root, and this one is minimum comparatively 7. So mark point as a minimum. See, now I am going to check about cascading cut. Okay, you can check with the algorithm, you can write on a paper, then you can solve it. Okay, now this is 26, this is y and this is z. Okay, in the cascading cut, if you check, 24 is actually, this is z, this is of course this is not nil, but see what I am going to do, I am going to cut this from here, right, cut this from here and make it as a root. Now 24, now I am check this is, now this is z and this is root. Now it does not have any root. So see 27, 24, you can check with the algorithm. We again, if you follow all the algorithm, we make 24 as a root using the algo which I have mentioned. And see, when I come to this node, this is the root node. So I am not going further. Now this is my Fibonacci heap in which I decrease the key. So this is the way we can decrease a key. Okay. Now for the next union, for this topic, I am we meet in the next lecture. Fine. Okay. Thank you.